Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through adding and subtracting fractions. So unfortunately, adding and subtracting fractions is usually harder than multiplying or dividing. And that's because you can only add or subtract fractions when denominators are the same. And people always forget this. When you add or subtract fractions, you only perform the addition or subtraction to the numerators, but not the denominators. So what do I mean by that? Well, if you have something like 3/7 plus 2/7, here the denominator, which means number on the bottom, is equal. So I only add the numerators. So I go 3 plus 2 is 5. I keep the same denominator. It's a very similar idea when subtracting, except you subtract the numerators. So if I have 9 over 11 minus 2 over 11, again, I only perform the operation on the numerators. This time, instead of adding, I subtract. 9 minus 2 is 7. And I keep the same denominator. Denominators don't change. All right, that's all well and good when the denominators are the same as they were here and here. But what about if the denominators are different? This is where it gets really tricky. If the denominators are different, we actually have to use a little trick to make them the same. That trick is finding the lowest common multiple of the denominators and using equivalent fractions. Let's look at an example. So let's say I have a half plus 2/5. Here, the denominators are different. The denominator here is 2, here it is 5. So we can't add them yet. What we need to do is make their denominators equal. So to do that, I look at the lowest common multiple of the denominators. So I look at the lowest common multiple of 2 and 5. What is the lowest number divisible by 2 that's also divisible by 5? So we just have to know these, and the answer to that is 10. 10 is the lowest number that is divisible by 2, but is also divisible by 5. If you didn't know that off the top of your head, you have to count up by 5. So you have to go 5, 10, 15, 20, until you find the lowest number that's also divisible by this one. Okay, 10 is the lowest common multiple of 2 and 5. So I have to find an equivalent fraction to this whose denominator is 10. I have to find an equivalent fraction to this whose denominator is 10. So let's look at this one first, a half. I want its denominator to be 10. So to get from 2 to 10, I need to times by 5. So I'm timesing the denominator by 5. But I can't just times the denominator. Whatever I do to the bottom, I must also do to the top if I want the new fraction to have the same value. So if I times the bottom by 5, I must also times the top by 5. So by doing the same to the top and the bottom, I come up with an equivalent fraction. I don't change the value of this fraction. So I need to do something similar to here. I want the denominator to be 10. 10 was the lowest common multiple of 2 and 5. So to get from 5 to 10, I don't times by 5. That'll give me 25. I times by 2. So once again, if I times the bottom by 2, I have to times the top by 2 to make it an equivalent fraction. Okay, so I have a half timesing top and bottom by 5. What I get is 5 over 10. 1 times 5 is 5. 2 times 5 is 10. For this one, I go 2 times 2 is 4. 5 times 2 is again 10. And I'm adding these fractions. See, a half and 5 over 10 are the same number. If I give you half a pizza, that you get the same amount of pizza as if I give you 5/10. If you get 5 out of 10 in a maths test, you've answered half the questions correctly. Similarly, 2/5 and 4 over 10 are the exact same number. They are both equal to 0.4. But the reason I've written 2/5 like this is because now it has the same denominator as this fraction. Now the two fractions have the same denominator, I can simply add the numerators and leave the denominators alone. 9 out of 10 is my answer. Let's do another example like this, but a bit quicker. So let's do 7 over 8 minus 5 over 6. So again, we have a problem. 8 and 6, the denominator of this and denominator of this are different. So we need to find the lowest common multiple of 8 and 6. So let's count up in multiples of 8. So 8 is not divisible by 6. 16 is not divisible by 6. But 24 is divisible by 6. 24 is the lowest number that is divisible by 8, but also by 6. So what do I need to do to make this denominator 24? I need to times it by 3. If I times the bottom by 3, I must also times the top by 3. So over here, remember, the lowest common multiple of 8 and 6 is 24. What do I times by 6 to get to 24? Well, that answers 4. So 6 times 4 is 24. So if I times the bottom by 4, I must also times the top by 4. So now I'm going to go 7 times 3 is equal to 21. 8 times 3 is equal to 24. 5 times 4 is equal to 20. 6 times 4 is equal to 24. Now, I've made equivalent fractions, so 21 over 24 and 7 over 8 are the same number, both equal to 0.875. These two are the same number, both equal to 0.83. So, now I have the denominators the same, I simply subtract numerators. So, 21 minus 20 is 1. And I leave the denominator as it is. I don't go 24 minus 24 is 0. I leave the denominator alone. And there we are. So let's just do one quick worded problem. So let's try this question here. Brad, Max, and Noah share a pizza. Brad ate 2/3 of the pizza. Max ate 3/10. What fraction is left for Noah? So let's figure out how much has been eaten. So if Brad ate 2/3, Max ate 3/10. Together, the fraction eaten is just 2/3 plus 3/10. So the principles don't change. The way we figure out what this is equal to is exactly the same way we did questions on the previous slide. So again, 3 and 10, different denominators, so I must first find the lowest common multiple. So the lowest common multiple of 3 and 10 is 30. 10 doesn't divide 3, 20 doesn't divide 3, but 30, which is a multiple of 10, is a multiple of 3. So I'm going to times top and bottom by 10 here, and I'm going to times top and bottom by 3 here. That will make denominators both equal to 30. And if I times bottom by something, I must also times the top by that number, so I have an equivalent fraction. So 2/3 is the same as 20 over 30. And then 3 times 3 and 10 times 3, that gives me 9 over 30. Okay, so these two fractions are equivalent, these two fractions are equivalent. Now denominators are the same. I simply add the numerators, add the top numbers, and I leave the denominator alone. So 29/30, that's how much has been eaten. But the question said what fraction is left for Noah. So if 29/30 have been eaten, there will be 1/30 left for Noah. Noah will get one whole pizza minus the 29/30 that's been taken away, that's been eaten. But of course, 1 is the same, 1 whole is the same as 30 over 30. So 30 minus 29 is 1, and I leave the denominator the same. So 1 over 30 is my answer. That's the fraction left for Noah. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.